Hello and good morning. My name is Richard Romanus, and I'm here today to talk about, or I'm a software developer at T-Mobile, and I'm here today to talk about the Puppet ENC, the ServiceNow scoped application. First, a little about me. I'm married with two wonderful kids, and when I'm not spending time with them, I love running, hiking, and biking. I have an extensive telecommunications background from AirTouch Cellular, Sprint, Ericsson, and now currently at T-Mobile. I also graduated from the University of Washington in 2013 with a bachelor's degree in computer science and software engineering. I started learning Puppet when I began working at T-Mobile about 5 years ago, and I've been using it ever since. At T-Mobile, like most big companies, we have a lot of data. Unfortunately, not all that data is centrally located. In fact, in a lot of cases, our data is isolated into separate silos or islands. At T-Mobile, we're using Puppet Enterprise to manage a lot of our server configuration management. That includes building and patching of servers. However, the configuration management was limited to only using the available configuration data, like server facts and hard-coded higher param values. We also use ServiceNow as our primary CMDB, or change management database, which is where all of our business data lives. And that includes stuff like our compliance data, business information, even physical location information about a server. However, we didn't have a good method for retrieving that business data and actually using it for configuration management. And that's where the idea for the Puppet ENC came from. The external node classifier, or ENC, is not a new concept with Puppet, but it requires actually writing the code yourself for classifying a server. The ENC I created is made up of three primary parts. There's the Puppet node classifier, or PNC, which is a Ruby script running on every compile master. There's the external node classifier, or ENC, which is a JavaScript running on ServiceNow. And then there's the application tables in ServiceNow that store the values of the data. I also use standard REST calls to communicate back and forth between the ENC and PNC. So this diagram shows a basic layout of the PNC and ENC and how it connects. So in ServiceNow, there's a global space, which contains a lot of the corporate CMDB data, and therefore has restricted access. However, in ServiceNow, there's also the scoped application spaces, where authorized users and teams can actually create their own applications within ServiceNow. And that's where the Puppet ENC resides, in a scoped application space. So when a server's Puppet agent checks into the Puppet master, the master calls out to the PNC, which then gathers information about that server. It gathers the fact information from the Puppet database. It captures Puppet-specific information from the Puppet console, and then actually the server's business information from the ENC in ServiceNow. PNC then takes all that information and merges it together, passes it back to the compile master for catalog compilation. And this is getting a little more detailed view of the ENC and PNC with some of the other Puppet components like the console and the database and how they interconnect. It also shows some of the primary global and scoped application tables that we're using in the ENC. Unfortunately, in the first version of the ENC, a lot of the scoped application data, scoped data had to be manually entered into the tables. So for the most part, the results were good. It performed well and was stable even at about 1 million check-ins a day. However, I did find that by replacing the console with a custom ENC, I now needed a method for overriding the ENC values, like environment. Before the ENC, we could actually override a server's environment with a fact value using a rule that we would set in the Puppet console. But now that we're using an ENC, that no longer worked. Another issue I found is that with no ACLs or access control lists set on the ENC tables or fields, and with no API, really, ENC API, for accessing the tables, it was really hard to let anyone have access to the tables. So for example, we really didn't want any user to get in and delete the production environment from our environment table, since that's the environment most of our servers are actually checking into. One of the immediate benefits we gained from using the ENC was the ability to use the business data that was already being stored in our CMDB for classifying a server. So even when a new server with no role comes online, it always has a business group already associated with it in our CMDB. This allowed me to create a default Puppet role manifest for each business group that we interface with. It also made it easier to create new role manifests for other role types a group might have, like a database, master, or console. However, as I mentioned before, without an API and lack of ACLs in ServiceNow, it really basically was limited to my team having access to that. So this is a little more detailed diagram showing how the ServiceNow business data and roles tie together with the Puppet roles and profile. So when the PNC calls out to the ENC, it only passes the server's cert name. The endpoint on the API in ServiceNow looks up that name in ENC server table. It then uses the data associated with from that table to look up the ENC role table. From the role table, it gets associated Puppet class information, passes that back with the environment and the other business-related data back to the PNC. The Puppet compile master then uses the provided class data to compose the catalog and pass that back to the agent. The parameter data that the ENC passes back, this parameter data, is available to all Puppet modules as top-level variables. So although the ENC version 1 did work, it was also very limited, and that was using a one-way GET call to gather data from ServiceNow. However, one of the critical roles that Puppet has been playing at T-Mobile for some time now is patching of our Linux and Unix servers. But with the challenges of scheduling and coordinating with server patching, there's been a lot of development on an automated patching method. Since ServiceNow is where many of our user interface request forms reside, it's also where the automated patching user interface and workflows reside. So with the first version of the ENC, I solved the problem of getting business data to Puppet for building and configuring of servers. But now we had the opposite problem, where ServiceNow needed to know the state of a server to determine if it was really ready for patching. However, when I realized that ServiceNow could use POST as well as a GET, I saw no reason why I couldn't make the connection a two-way connection and pass data both ways. And that's what led to the code upgrade of Puppet ENC and PNC to version 2.0, which uses a two-way communication to pass data back and forth. With the goal of improving automated patching, we needed a method of checking the status of the server before putting it into the patching workflow. So changing the REST call from a GET to POST between Puppet and ServiceNow allowed me to pass status of the server back to ServiceNow and actually store it into a table. I then created an endpoint API in ServiceNow that looks up that stored server status to determine if the server is really ready for patching. I also had to create a Ruby wrapper script that runs our operations team server shell script and then saves the values in a fact file. And this is the overall architecture of version 2.0, which is actually the current running version. And as you can see, I changed the ENC endpoints from GET to POST and added a new patch ready endpoint. This provided our operations team's time. The patch ready endpoint is called by the ServiceNow automated patching workflow here. Whenever a user schedules a server for patching, and then also again, actually before the server goes into patching. This provided our operations team time to address any server issues if necessary, switch to manual patching. I also added a new external API interface. This allowed user access to their ENC data. The external API actually runs on a container with restricted access to the ENC, but allows users the ability to read and make some minor changes while still restricting them to overall access to the ENC data and ServiceNow data. As I mentioned earlier, I had to create a wrapper script that runs the operations team's server check script and save a FAQ file. The results for 2.0 have been good. It's performing well and stable at about 1.5 million check-ins a day. But there have been many new benefits related to gathering of using server data. The external API, despite being very limited, has still made the ENC a little more usable by some of the other teams, since I still don't have the table fields locked down with ACLs. However, some of the other cons that existed in the latest ENC version include extensive customization for our PNC, very customized, no auto creation of the default role entries in the business groups for a business group in the ENC role table, and no auto deletion of decommissioned servers, and then also the no data caching with the ServiceNow data. So as we've become more reliant on that ServiceNow data, having that data always available in our Puppet code is very important, because without it, we tend to fall back to default settings. And though this might be okay in certain situations, they can be very dangerous in other situations, like when you consider location information. So despite the list of cons, the benefits of the ENC can easily be seen with the time saved from automated patching. The patch-ready API is a key part of ensuring that the automated patching workflow runs stable and successful, and the time saved by automating patching has been huge. Taking into consideration the communication and coordinating between teams, estimate we're saving about 20 minutes of time per server with automated patching. And with about 10,000 servers using automated patching, that saves us around 3,300 hours per quarter, or about 13,000 hours a year. The first version of the ENC and PNC was released in 2018, and there were some minor releases after that to fix some of the minor issues that I had and add some basic functionality. But then version 2.0 was released about 9 months later in August of last year. Version 3.0 of the ENC is currently in beta testing and scheduled to be released actually next month, July. I rewrote most of the code for both parts. However, the overall architecture hasn't really changed a lot. I had to make some table and API changes for a new business data model that TMobile is switching to, since the business data is actually at the heart of the ENC classification. Version 3 of the ENC and PNC is basically a total rewrite and should be more stable and with improved performance. Now that I have a better understanding of the internal interactions between ServiceNow and Puppet, I believe the new version should be more stable with better handling of non-standard data encounters. I also finally added some of the ACLs to some of the key critical table fields, like environment. I also added auto creation of a default role table entry for every business server that checks in. At the request of our operations team, I made the captured server check data in ServiceNow more usable. I moved the data into its own table that can be now searched and sorted by the ops personnel to help them identify common server failures. It's currently in version 2.0, which is basically big blocks of string text, which is not very usable. Also in the PNC, I updated the Ruby override file to be a YAML configuration file, which then can store configuration settings and also overrides. That makes the PNC more generic and less customized to each of our Puppet clusters. So what's next? One of the major benefits of creating your own classifier is the ability to expand its functionality as you see fit. Some features I'm looking at adding are adding a new table for storing specified Puppet facts in ServiceNow that can be used in either workflows or just presented to privileged users. For example, our application team. They might be able to see some of their facts on their servers that they don't have access to normally get into. The ServiceNow is not just a CMDB. It's also where many of our teams actually interact and go order things like new features, user access, and even new hardware like servers. So with the two-way communication between Puppet and ServiceNow, and with a common user interface that many teams are accustomed to using, there are numerous opportunities for creating custom user interfaces for our data. For example, it'd be pretty easy to create a user interface that shows the server owner the current version and or status of their applications on their servers. That data was already being captured in effect. Challenges. Well, there was definitely no shortage of challenges on this project. Developing in ServiceNow for the first time was a big first step. Understanding all the tables, fields, workflows, and relationships between everything was a struggle at first, and I'm still learning stuff all the time. But since ServiceNow is our primary CMDB, it has a lot of data in it. And there are unfortunately a lot of fields and tables are not standardized. And therefore, I'm often forced to work around some of the edge cases or weird data we might get back. And as I mentioned earlier, with ENC, when you remove the functionality from the Puppet console, you lose some of the functionality the console has, like the overrides. So thank you for attending my presentation. If Here's my basic contact information at T-Mobile. Feel free to reach out to me with any questions. I also want to say extend a thank you out to my team, the automation team, and the ServiceNow team for all their support. Any questions?
Thank you so much for that. There are some questions out there, Richard. Let's see. The first question came in on Slack, and it is from Nick. And the question is, why didn't you use the PNC to make REST calls into ServiceNow? What was the motivation for creating the scoped app within ServiceNow?
Well, as I stated, that's where a lot of our data was already being stored. The PNC is just what the compile masters used to call out to the ENC. They needed some method to make that call out. And since ServiceNow, like I stated earlier, has all of our business data already in it, it just seemed natural to grab that information and use it for configuration management. If there was data was stored in a different location, we probably would have looked at that as a possibility. But trying to gather that data in and use it was the big reason to reach out to it. And then, like I said, there's all sorts of other data in there that we can still grab and use and pass back and forth.
Thanks for answering that. Also, one within the chat is from Ryan. Are you using a custom module for patching servers? I think he had a second one also. And is this all custom coded, or is the built-in Puppet integration in ServiceNow being used? So it looks like he has two questions.
It's all custom. In fact, even the patching stuff. The patching had been set up a while back. We actually started using Puppet for patching, and one of our other engineers had developed our patching workflow for our Unix and Linux servers. So that was already in place. Just they had started making it automated. We had working with ServiceNow for orchestration, they'd made that automated. But then there was the high failure problem. And so that's where when the two-way communication allowed to solve some of those problems of failures, the failure rate. Since now we could actually get status of the server before putting it into patching.
Oh, it looks like there was another one from Nick. Also curious if any of this is open source or available in the ServiceNow marketplace.
No, unfortunately not. Like I said, I basically wrote all this pretty much myself, customized it. I am trying to make it more standard, like I said, the PNC, make it more less customized in the hopes that in the future we can possibly share it as an open source project, but at the moment it's not.
Okay, one more question. Any reason the server check result was not stored as a fact in PuppetDB? And this was a question in the chat room from Michael.
The server check. I'm assuming you're talking about the operations check. Well, operations had the shell script that they use that's very familiar, and considering the checks it's doing, it makes sense they're using shell scripts. But to try and modify their shell script to write something that turns out as a fact that's easily readable and passed into ServiceNow. In ServiceNow, it can understand JSON, but beyond that, there's not a lot of different data types it understands, and so JSON made a lot of sense, but to write JSON in a shell script is not great. And so I have their shell script actually exports a CSV, and then my Ruby wrapper takes that CSV, converts it into JSON with the time that it ran, and then also the exit code information. So the wrapper script is just maybe in the future we'll be able to get rid of that and replace it with just a script that they're using. But for right now, we have a wrapper for that.
Okay, I think that is all for questions. Really appreciate it. Thank you so much, Richard.
Thank you.